the last part for this topic already, chapter 4. Okay, the last part of in terms of phenomena that we talk about, it is diffractions. What is exactly a diffraction? I want you guys to think a diffraction as in spread out. An easy way for me to show you is this. When I speak like this, you guys can hear me. But whenever I use something like this, you can actually hear it quite louder compared to normal like this. That is exactly a diffraction. Diffraction, it must be going through like a gap. I mean, like a gap in between, or it can be a blockage. You guys still can hear me. So either an obstacles or a gap is still classified as diffractions. So in order for the diffractions to learn how to draw the diffractions, there are two different ways that you can draw. The first one, let me just draw it like a small gap. Then I think I have to draw 4 because I'm afraid that your teacher show you a different thing. Small gap, big gap, then small obstacles, then big obstacles. Okay. Now, think of it like the diffraction is spread out. So let's talk about the gap first. This is a very small gap. This is a very big gap. Okay. So you see the gap in between, right? Okay. Now imagine we're talking about water wave, yeah, water wave. So whenever there's a wave go through here, the moment when the wave travels through here, what will happen is the shape of the wave will look like a Wi-Fi signal. Therefore, after a small gap, the wave will become like this. One thing that I want you guys to pay attention to, whenever we are drawing any of the diffraction is the wavelength is the same. No matter what, regardless whether 1, 2, 3, 4, your wavelength always the same. Therefore, you notice when I draw, I kind of gauge the exactly the same wavelength. So whenever they go through a small gap, this is a pattern that they will show. Whenever they go through a big gap, what kind of patterns that they will show? They will show something like this. They will show whenever they go through a big gap. Imagine that it is spread out, and continue to draw the same gap. I mean, same wavelength. But what show different? It will be at the outside here. They will just bend a little bit. The wave will just bend a little bit. The easiest way for me to explain it to you: when you go to any of the stream, river, when the river cross or when they pass by a rock, you will see a swirl behind the rock, right? That swirl, it's where this one is. But whenever it's a bigger gap, the swirl will be smaller. But whenever it's a smaller gap, you can see the swirl is bigger. That is the things here. Yeah. So now, small obstacles and big obstacles.
Next to the wall.
It won't be connect pulling to the wall. No. It won't. It only a little bit. It only like bend a little bit, a very, very subtle bend, not bend a lot. No. There won't be like bending towards no. It means that the bending here not so obvious. It's only bend a bit. Okay. So whenever it is a small obstacles and big obstacles. So whenever they go through a small obstacles, what will happen is same thing, draw the same wavelength first. Usually when they ask you to draw, you just draw 3 waves right after whatever thing it is. You notice? 3 wave, 3 wave, 3 wave. Always 3 wave. Remember just now I said it will bend in to make a sole, right? Same thing, it will bend towards, but this one bend a bit more, bend a bit more, bend a bit more. Okay? Whenever it's go through about this, just make it. Same thing happen to here. 1, 2, 3. After this, it will be. Oh, okay, there's some things that I need to point out is you notice that when I draw this, I'm closing the gap for this. Whenever this, I'm opening wider. So yeah. And for this one.
Because there's 2 waves. 2 separate waves.
No, this is actually a guideline that how much that it bends.
Oh.
This is just a guideline how much it bends. Because we know any of the water wave goes, whatever outside not affected. It's only the affected one inside. And for this one, it's similar to the big gap. It only has very subtle effect. Only like a bit only. This is a subtle effect of blending. But why I want to bring this up is because in order for us to make diffractions to be obvious, if I want to make the diffractions to be more obvious, I have 2 things to do. Number 1, we can only do it like make smaller in terms of gap or obstacles. You see here, whenever I'm drawing the 2, I emphasize a lot in terms of whenever they are smaller, the bending effect is very obvious. But whenever they are bigger, the bending effect is only very subtle. Because when we make something very small, that if the diffraction is much more obvious compared to this and this is very easy. Then, number 2, what we can do is increase the wavelength. Let's say, for example, imagine that we are actually doing this experiment now. We are actually doing top-down view. If I tap the water continuously, you cannot, it's very hard for you to identify, oh, this is my second wavelength, this is my third wavelength. But if I tap 1/2, the first wave you see, then I tap the second, you see the second wave. So that far distance is actually telling us increase the wavelength to see that diffraction is much more obvious. Only these 2 things will make the diffractions to be obvious. Or you can see that whenever the wavelength and the gap size is the same, it's also have the greatest diffractions. Okay, so these are the things that you need to know in diffraction. All right, I will stop recording, take a photo, and send it. Yeah, anything to clarify?
In class, like, you should show the model, like a diagram, like where